In this video, I'm going to show you how to do polynomial long division when the divisor is linear and the dividend contains missing terms. So here the dividend is missing an x squared term. We've got an x to the third term, we've got an x term, but there's no x squared term here. So how do we deal with this? Well, to start off, we're going to have a very similar setup as before. So we're going to draw our long division diagram here, and on the outside of the diagram, we'll put our divisor, we'll put our x plus 3, and on the inside of the diagram, we'll put our dividend. So we'll start off with our x to the third, but to address the x squared, the missing x squared, we need to write down a 0 x squared term here. We want to write down a coefficient for each one of the powers from the highest degree until the constant. So we're going to include this 0x squared just because it'll organize all of our work in our long division as we go. So 0x squared, and then we've got our 2x plus 15 plus 2x plus 15, and we're ready to begin. So now it's just the same as usual, except we've got a 0 coefficient here. So to start off, we're going to take the highest degree term in the dividend, that's x to the third, and we need to divide that by the highest degree term in the divisor, which is just our x. So x to the third divided by x, and that gives us a result of x squared. So that's going to be the first term in our quotient. X squared goes up here, and to figure out what we need to write in the row below, we need to multiply our divisor, x plus 3, by that result, x squared. So x plus 3 times x squared, and that produces just x to the third plus 3x squared. So we'll write that in the row underneath. So line it up, x to the third goes with the x to the third, and then plus 3x squared. And we're going to subtract that from the original dividend. Okay, so x to the third minus x to the third, that's just 0. These cancel out, which is good because that's the whole purpose of choosing this x squared. So that when we multiply and subtract, the leading terms cancel out. And then 0x squared minus 3x squared is just negative 3x squared. And for the next iteration, we bring down that next term, plus 2x, and we perform the same procedure again. So this time we need the highest degree term of this row, which is negative 3x squared, and then we have to divide that by the highest degree term in the divisor, which is still just x, and when we do that, we get a result of negative 3x. So that's going to be the next term in our quotient, negative 3x, and now to figure out what we need to write in the row, we need to multiply x plus 3, our divisor, by that result of negative 3x, and when we do that, we get negative 3x squared minus 9x, and then we write that here, negative 3x squared minus 9x, and we need to subtract that. Okay, so negative 3x squared minus negative 3x squared, it's like negative 3x squared plus negative 3x squared, that cancels out, which is good, that's what we wanted. And then 2x minus negative 9x is like 2x plus 9x, so just 11x. And lastly, we bring down our constant, plus 15, and we have to do one more iteration. So take that highest degree term, that 11x, divide it by the highest degree term in our divisor, which is x. We get a result of 11, and we put that result up in the quotient, so plus 11, and then to figure out what we need to write under this row here, we need to multiply our divisor, x plus 3, by that result of 11. So x plus 3 times 11, and that gives us 11x plus 33. Okay, so now we put that under here, 11x plus 33, and we subtract. 11x cancels with 11x, great. And then 15 minus 33 is just negative 18. So that's our remainder. Remainder is negative 18. Okay, so let's organize our findings. Let's write this down. So from before, we know that the general rule is that our dividend divided by our divisor, when we do long division, we get a quotient and a remainder, and that tells us that the dividend divided by the divisor is equal to the quotient plus the remainder over the divisor. Okay, so that's our general rule, and in this particular problem, let's fill in our information. So the dividend was x to the third plus 2x plus 15, and the divisor was x plus 3. And now that we've done long division, we have the quotient and we have the remainder. So our original fraction here is equal to the quotient x squared minus 3x plus 11, and then plus our remainder, so plus negative 18, and that remainder is divided by our divisor, which was just x plus 3. So this is our conclusion from doing the long division. We can express that original division as this quotient plus that remainder divided by the original divisor. Here's another example where the dividend contains missing terms, and we've actually got a lot more missing terms here. We're missing an x to the third term, we're also missing an x term, we're also missing a constant term. But the process is still the same. We're going to set up our long division problem. So let's write our long division diagram here. And we'll make it extra long because we're going to be including all these missing terms as zero coefficients. So start off, put our divisor on the outside. 2x minus 1 goes on the outside. And then on the inside, we put our dividend. So start off with 16x to the fourth. And then our x to the third term is missing, so we just put a 0x to the third term. And then we've got our 4x squared. And then our x term is also missing, so we put a 0x. And our constant is also missing, so we put a 0. Okay, so this inside with all the zero coefficients, that's equivalent to our original expression, but we've written all the zero coefficients because it's going to be important to organize our long division work. Okay, so now we can actually get started with the long division, and our first step, take the leading coefficient of the dividend, that's 16x to the fourth, and divide that by the leading coefficient of the divisor, which is 2x. Okay, and that result just comes out to 8x to the third, so let's put that in our quotient up here in the x to the third column, so 8x to the third, and then to figure out our next row, we have to take the divisor, 2x minus 1, and multiply it by 8x to the third. And when we do that, we get a result of 16x to the fourth minus 8x to the third. So we'll put that under here, 16x to the fourth minus 8x to the third, and we'll subtract. Okay, so the 16x to the fourths cancel. That's what we wanted. Good. And then 0x to the third minus negative 8x to the third, well, that's just plus 8x to the third. All right, so now we bring down the next term here, plus 4x squared, and we repeat the process again. So we take the leading term here, highest degree term, 8x to the third, divided by the highest degree term of the divisor, which is just 2x, as we saw before. And when we divide, that comes out to 4x squared. Okay, so 4x squared will be in our quotient. And then to figure out what our next row is, we take that 2x minus 1 divisor and multiply it by that result of 4x squared. And our our result then when we multiply is just 8x to the third minus 4x squared. So we'll put that under here, 8x to the third minus 4x squared, and we're subtracting that. And when we subtract that, our 8x to the third minus 8x to the third cancels. Good, that's what we want. And 4x squared minus negative 4x squared is really just 4x squared plus 4x squared, so 8x squared. All right, bring down our next term, plus 0x, and let's take our highest degree term here, 8x squared, and divide it by that highest degree term in the divisor, which is still just 2x, and we get a result of 4x. So that's in our quotient, so plus 4x. And to figure out what our next row is, take our divisor, 2x minus 1, multiply it by that result of 4x, and we get 8x squared minus 4x. So we'll put that 8x squared minus 4x below here, subtract, 8x squareds cancel, good, and then 0 minus negative 4, 0x minus negative 4x is just plus 4x. And last time, let's bring down our last term here, plus 0, and repeat the process once more. So take the highest degree term here, which is just 4x, divide it by that highest degree term of the divisor, 2x, and our result is 2. Okay, so 2 goes as part of our quotient, and then to get our next row, to get our remainder part, we multiply 2x minus 1, our divisor, by that result of 2, just 2, and then when we do that, we get a result of 4x minus 2. So let's write that under here, 4x minus 2, and subtract. The 4x's cancel, great, and then 0 minus negative 2 is just 0 plus 2, so 2. So our remainder then is 2. Okay, so now we can go ahead and collect our results. So result was that our original division problem, 16x to the fourth plus 4x squared divided by 2x minus 1. That fraction of the dividend divided by the divisor is going to be equal to the quotient, which we have up here, 8x to the third plus 4x squared plus 4x plus 2, and then plus our remainder, plus 2, and the remainder is divided by the original divisor, so 2 over 2x minus 1. And there we go. That is our result from doing the polynomial division. In the future, we'll also learn how to perform polynomial long division when the divisor is nonlinear. Here we've just been working with a linear divisor, just consisting of an x and a constant, but in the future we'll learn how to deal with this when there's also x squared terms or x third terms or even higher.